Let's look at some examples of how to solve quadratic equations using the zero product property. In the yellow box, you can see we have our definition for the zero product property. If the product of two factors is zero, then at least one of those factors must be zero. Let's take a look at this with just basic numbers first. So let's say I told you I had two numbers, and when I multiplied those numbers together, the product was zero. And then let's say I told you, well, one of the numbers is 3. Could you guess the other number? Well, yeah, I bet you could. In order to multiply 3 by another number and obtain a product of 0, that other number must be 0, because 3 times 0 would be the only way to obtain 0 as a product. So if one of the numbers is 3, the other number has to be 0 if the product is 0. So now let's take a look at that in terms of the binomial factors. If I have x plus 5, binomial x plus 5 times the binomial x minus 2 equals 0, then either the x plus 5 binomial must equal 0 or the x minus 2 binomial must equal 0. So when you're done using the zero product property and you're in your final steps, you get two linear equations and they're set equal to 0, and all you have to do is isolate x and then you obtain two solutions. Let's take a look at number 1. We have x squared minus 7x minus 18 equals 0. So you'll notice the difference between this equation and the equation we looked at in the definition. This equation does not have a factored trinomial yet. So our job is to factor it into two binomials. So I'm looking for two binomials that the product of those binomials is equivalent to x squared minus 7x minus 18, and I want to set them equal to 0. So quick little factoring review here. I know I need to start with x and x because that's how I will obtain the x squared. But now I need to think of numbers that multiply to negative 18 that will also add to negative 7. So hopefully you can understand why my choices would be negative 9 and 2. Negative 9 times 2 equals negative 18, but negative 9 plus 2 equals negative 7. Now, since my leading coefficient is 1, I'm ready to place those magical numbers inside my binomials to obtain my two factors. So my two factors are x minus 9 and x plus 2. You could pause the video and check the multiplication of those two binomials and distribute and make sure you get x squared minus 7x minus 18. But I'm pretty confident that we have our factors of x minus 9 and x plus 2. So now here's how we apply the zero product property. The binomial x minus 9 equals 0 and the binomial x plus 2 equals 0. So when we solve these two linear equations, we obtain our two solutions. So our first solution is x equals positive 9. And when we subtract 2 from both sides of the other equation, we get our second solution, which is x equals negative 2. So our solution set contains two values, negative 2 and positive 9. Okay, let's take a look at number 2. We need to factor 2x squared plus 5x minus 12. Notice our lead coefficient now is not 1. Our lead coefficient is 2. So we will use the AC method here just to give you a brief review of factoring when your leading coefficient is not 1. So I label A as 2, B as 5, and C as negative 12. The AC method tells me to start by multiplying A times C. 2 times negative 12 equals negative 24. Then I need to find factors of negative 24 that will also have a sum of positive 5. So here you can see I've listed all the factors of 24, and then keep in mind one of those two factors will have to be negative in order to multiply to a negative 24. So when I look at 3 and 8, I can see that if the 3 has the negative sign, then I can also find the sum of negative 3 and positive 8, and it will add up to the 5 in the middle, and that's what I'm looking for the AC method. I want to add up to the B value of 5. So then what I do is I use the factor by grouping method. So that 5x, I'm going to turn it into two terms. So I'm going to rewrite my trinomial, but I'm going to rewrite it as 4 terms. So I start with 2x squared. But then the plus 5x becomes minus 3x plus 8x, which is still equivalent to a middle term of 5x. And then I end with the minus 12 equals 0. So now I'm able to use factor by grouping. The first two terms have a GCF of x, and the remaining binomial is 2x minus 3. Then I'm going to put a plus sign because that was my next symbol. I look for the GCF of 8x minus 12, and the GCF is 4. And guess what? The remaining binomial is also 2x minus 3. So this is where I get really excited, and I always tell my students, do your happy dance. Ooh, ooh. Do your dance. And the reason you're dancing and celebrating is because your binomials match. That means you're on the right path. So give yourself a pat on the back and let's keep going. So the binomial 2x minus 3 is one of my factors. And then I pick up the GCFs, x plus 4, to form my other factor. And now I have a factored trinomial, so I can set each binomial equal to 0 to use the zero product property. So for 2x minus 3 equals 0, I will add 3 to both sides and then divide by 2. So x is 3 halves. And then for x minus 4 equals 0, all I have to do is subtract 4, so x equals negative 4. So my solution set contains two values, negative 4 and positive 3 halves. Let's take a look at number 3. I hope you recognize number 3 as a difference of squares. That was one of our special factoring patterns. It will factor to a pair of conjugates. Since 8 times 8 is 64, my binomials are x plus 8 and x minus 8. And I set each of those equal to 0. So I'm going to obtain two solutions, either x equals negative 8 or x equals 8. So my solution set contains negative and positive 8. Okay, in number 4, I have to first set the equation equal to 0, which means I need to subtract the value 12 from both sides of the equation. So on the left, I'm going to get x squared minus 4x minus 12. On the right, I'm going to do 12 minus 12, which gives me x squared minus 4x minus 12 equals 0. Now I'm ready to factor to use the zero product property. Remember, it's called the zero product property because you can only use it when your equation equals 0. So now I need to find factors of negative 12 that add to negative 4. So my choices are x minus 6 and x plus 2 to equal 0. And then I set x minus 6 equal to 0 and also x plus 2 equal to 0. So again, I get two solutions. This time the solutions are x equals 6 and x equals negative 2. So my solution set contains the solutions negative 2 and 6. We have 2 more equations to do in the next video, but I hope you enjoyed these 4 equations.